everyone. Today I wanna talk about what bit truncation is. When you convert a data type to a smaller data type, the computer system does bit truncation. And let's see the example with two numbers 92800 and 125568. And let's try with 92,800, and I'll assign this number to a data type with int, and let's print out the binary representation of this decimal number, and let's see the result by running, and it gives these binary numbers, and I'll just write it down here. And then because short type consists of 2 bytes, which is 16 bits, and int type consists of 4 bytes, which is 32 bits. And if you try to convert the data with int type to short type, it truncates the leading bits to fit into 16 bits. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. We've got 17 bits. So the computer system truncates the leading bit and gives these binary stores these binary numbers to short type data with a short type. And let's see if it's true. Um, let's make a set that consists of meaningful bits of these binary numbers. So because these bits are only the bits that we need to convert from this binary number to decimal number. So 90, write that down here. Copy it and paste. And count it from the lowest bit. 1, 2, 3, 4, 5, 6, 7, 8, 8, 9, 10, 10, 11, 12. We've got one bit. 12, 13, 14, 14, 15, and let's see, before we see the result, um, let's see the decimal number of these binary numbers. And 2 to the 8 plus 2 to the 10, actually should be 2 to the 7 plus 2 to the 9 plus 2 to the 11 plus 2 to the 13 plus 2 to the 14. It gives this number 27,264 in decimal form. And now let's see if if actually the computer system works this way. Here, int num, I've got int num that stores 92,800, and if I try to type convert it to a short type, which is smaller than int, and short consists of two 2 bytes, and actually originally 92,800 consists of 17 bits, but because short type cannot fit, this number cannot fit into all of these bits cannot fit into this short type, so it truncates the bit. It does bit truncation, and only the 16 bits are left to store in short num. And this short num, um, if you convert these binary numbers, which is stored in data short num, then if you convert it to decimal number, it will give 27,264. And in the case of unsigned, it gives the same number because the most significant bit is 0, so it doesn't affect the for the effective result of converting it to decimal number. So let's see the result. See that you've got 27,264 for short num and 27,264 for unsigned short num. And int num converted to short int is stored in ushort int num, which is declared with unsigned short int, and it's printed out below short num. And these two numbers are the same, and it is the same result with what we have calculated just before. Now let's see a different case in which the most significant bit is 1, and let's try it with this number. And let's see the case of let's see what it gives in binary numbers. I've got two binary functions up here. It gives these binary numbers 12, 55, 68, gives these binary numbers, and it differs from the earlier number 92,800. Only this bit differs, and again, if you type convert, if you type cast it to short, which is consists of 16 bits, but int consists of 32 bits. Although int can store more than 16 bits, but short type cannot, so it does bit truncation, and then only these bits are left to be stored to short num. And in this case, because this most significant bit is a meaningful bit, and either it'll apply according to the declared type, either of 2's complement or an unsigned. And unless you declare it with unsigned, it applies 2's complement. So let's see the 2's complement case first, and let's calculate it before we see the result first. Again, let's make a set to make it easier for calculation. One, two, three, 4, 5, 6, 7, 8. It has 8 with the meaningful bit. 9, 10, 10, 11, 12, 13, 14, 14, 15, and 16. And let's calculate the 2's complement case first. What we wanna calculate is these binary numbers, and what it'll give the number when we print out short num. So this is the power for the most significant bit, this bit. So because now for this case it applies 2's complement, it gives negative number, so minus 2 to the 15, and then you add all the positive numbers down to here. So plus 2 to the 14 plus 2 to the 13 plus, now it's 12, 2 to the 11 plus 2 to the 9 plus 2 to the 7, and it gives minus 5504. Let's write it down here, minus 5504. And now let's calculate it for the unsigned case, and this time we'll add positive number for the most significant bit, 2 to the 15 plus 2 to the 14, 2 to the now it's 14, 2 to the 13 plus 2 to the 11 plus 2 to the 9 plus 2 to the last bit, 2 to the 7 is gives 66032. Write it down, 60032. And now let's see if this number, the short num, gives minus 5504, which applied 2's complement, and u short num gives 60032, which applied unsigned through for representing the data. So let's run it and see the result. And here you can see it Short num matches the number we have calculated earlier from the binary numbers, and then the below unsigned short num gives 60032, which matches the earlier number we have just calculated. And yep, up to this point, I've covered about what bit truncation is and what happens when what the computer system does when you try to convert to a data type to a smaller data type, and which is called bit truncation. And I hope you enjoyed this video, and thanks for listening. Bye.